This is section 3.5b, exponential and logarithmic models. Today we're going to talk about the logistic growth model. And it's a pretty complicated model. It actually is derived from calculus, and since it requires knowledge of derivatives and integrals, things that you'll learn in calculus, I'm not going to go through the derivation here. But I just wanted you to see what it is, so that you can recognize it and know what it's for. Logistic growth basically applies to things that grow quickly at first and then less quickly later. Growth that is slow, then rapid, then slow again. Okay, for example, population growth follows a logistic growth model because it tapers off with people, dying, the mortality rate, and also with the maximum number of people that can be reached, based on resources in a given area. So population growth follows this model. And another thing that follows this model is the spread of contagious diseases. And we're going to talk about the spread of contagious diseases just because it's kind of interesting and relates a little bit to the plague that you studied in history. Now, in this model, A is the initial number of infected people. All right, so let's say in a pool of people, could be a city, could be a school, you start with one infected person, or two, or three, or 10. It's just the initial number of infected people before a disease begins to spread. K is the total number of people. Includes the healthy or sick. It's just the total number of people. B is the rate constant, as usual. B is always in these models the rate constant. And T is the time. Okay, so make sure you write down this logistic growth model. Y equals AK divided by the quantity A plus K minus A times e to the negative bt. And this model will give us the curve that's pictured on the screen. So we look at an example of logistic growth with spread of contagious disease. On a college campus of 5,000, one student is infected with a contagious flu virus. The virus spreads with a rate constant of 0.8. Classes will be canceled when 40% of the students have the virus. How many days will this take? All right, so the first step is to set up our equation, and we do that as usual by translating English into math. Okay, so try to come up with an equation for this problem. Pause the video, try to do that, and then resume when you have an equation. So this is how we start. 5,000 times 0.4, 40%, is 2,000. So we want to see how many days it'll take to get 2,000 sick people on campus. We set that 2,000 equal to our model, which is AK divided by A plus K minus A times e to the negative bt. And from there, we simply plug in our numbers and find T. So once again, pause the video, try to do that on your own to get T, and then resume when you have an answer. So proceeding now, 2,000 equals 5,000. Okay, we got 5,000 because A, which is my initial number of sick people, is 1. K, the total, is 5,000, and 5,000 times 1 is 5,000. Divided by the quantity, okay, A is one sick person, plus K minus A, total number of people minus number of sick people is 4999. E to the negative 0.8 t, because the rate constant, the b, was given 0.8. And from here, it's just a matter of calculating to get t. So first I multiply both sides by 1 plus 499e to the negative 0.8 t. Then I divide both sides by 2000. Then I subtract 1 from each side. And then I can calculate t equals 10.14 days. And of course, I didn't go through all the steps for that because by now you're pretty familiar with how to do it, taking the ln of both sides, etc. 10.14 days. And so after that amount of time has gone by, 40% of the students will be sick and classes will be canceled. I guess that's good news for some. Of course, it's kind of sad when 40% of your students are sick. Now, let's look at another example of a model, a mathematical model using E, and that is the learning curve. You've probably heard of learning curves before. Learning curves are basically, they're based on the simple principle that when you start learning a new skill, usually you learn it quickly in the beginning, but then to really get proficient, to become an expert, takes a lot longer. Okay, and that's kind of represented here on the graph. Level of mastery is on the left. That would be our y coordinate. And time is our x coordinate, or my t, rather, variable that I'm using. And so when I start to learn a skill, well, after a few days, I, quickly pick up at least the basics. But then when I reach a certain point, of mastery, then to become really skilled and an expert in whatever I'm learning would take a lot longer. Okay, because your mastery increases less and less as time goes on. So y equals a times 1 minus e to the bt is the model. This is growth that is rapid at first, then slow. A is the maximum level of mastery. On this particular graph, it's 100. B is the rate constant, as usual, and t is the time. So this is the basic shape of a learning curve. Let's look at a specific example of a learning curve. Y equals a times 1 minus e to the bt. A basketball player is trying to improve his free throws by taking 200 shots every day. Y equals 200 times 1 minus e to the bt is the learning curve, but of course b is not specified yet. If he can hit 150 out of 200 shots after 10 days of practice, what is his learning curve? Alright, so now we can figure out exactly what the learning curve is, and we're going to have to find b to do that. So take a moment, just pause the video, try to find b on your own, and then resume when you have it. Alright, you should have set it up like this. 150 equals 200 times 1 minus e to the 10b. 10 days, that's why it's 10b, and the 150 because that's how much or how many shots he can hit out of 200. The maximum level of mastery. 200 is the maximum, 150 is what he achieved. Okay, so now we just continue with our Algebra 1 steps. Divide both sides by 200. And then what I do is subtract 1 from each side. Then I can drop the negative. 0.25 equals e to the 10b. I can take the ln of both sides. And I end up with my learning curve. Okay, since the problem asks us for a learning curve, it wants us to give the equation, not just to give, the value for b, but rather to give the equation. And so the equation is 200 times 1 minus e to the ln 0.25 divided by 10t. That is the learning curve. After how many days of practice will he be able to hit 190 out of 200 shots? Okay, pause the video, try to figure this out, and then resume when you have an answer. Okay, so we're going to use the learning curve that we already found in the previous question. And we set that up, y equals 200 times 1 minus e to the ln 0.25 divided by 10t. And then we simply proceed by plugging in 190 for y, because that's the goal, is to be able to hit 190 out of 200 shots. And then we just divide both sides by 200. Subtract 1 from each side. To drop the negative, so we end up with 0.05 equals e to the ln 0.25 divided by 10t. ln of both sides, because you want to get rid of the e. ln 0.05 equals ln 0.25 divided by 10t. Finally, we just divide both sides by that quantity in brackets, which is basically our b. And we end up with something that we can just evaluate on our calculator. So you should have got 21.6 days equals t. It'll take him 21.6 days of practice before he can hit 190 out of 200 free throws. Here's the classwork. These are review exercises because we're going to start reviewing for the exam. These problems, beginning on page 271, these problems include some of what we just went over and also previous material. So make sure that you copy these down correctly. Would be good to get a head start if possible, but as always, there will be time in class for working together on these problems.